This video is about multiplying monomials, and as a quick review, we will take a look at multiplying powers of the same base. So when you multiply two powers of the same base, you add the exponents. The converse of that law is when you divide two powers of the same base, you subtract the exponents. An example of multiplication would be something like 3 squared times, the dot means times, 3 exponent 5. These both have the same base. Remember, the base is this part, the exponent is up here. So they both have the same base. So basically we say, okay, we write down the same base and we add the exponents. 2 plus 5 equals 7. So the answer to this is 3 exponent 7. Okay, another rule that goes along with this is the power of a power. So in other words, if you had 5 exponent 7 to the power of 2, that would be the same as 5 exponent 7 times 5 exponent 7. And if you look at this, it's like saying 5 exponent 7 times 5 exponent 7, you add the exponents, which is 14. However, the shortcut, as you should remember from last year, is 2 times 7. If I'm going to add 7 twice, it's the same as going 2 times 7. And as a quick review, also with division, if you're going to divide two powers with the same base, say 5 exponent 7 divided by 5 exponent 5, you can also write it like this. 5 exponent 7 divided by 5 exponent 5. The answer would be, write down the base, subtract the exponents. This is all from last year. Okay? There we have. So there's a quick review. Okay, so taking a look at what we are doing in class right now, which is multiplying monomials. Okay, so we talked about the difference between monomials, binomials, polynomials, and monomials are expressions with one term. So we'll call the monomial is one term. Mono means one, bi times 2, tri means 3. Okay, monomials. Okay, so let's just do the similar examples. So x squared times, dot means times, x exponent 6. So the question we first ask ourselves, are they the same base? Well, yes, they are, because whatever x is here, it has to be the same thing here. So if x is 4, this would be 4 squared, this would be 4 exponent 6. So the same rule applies. You write down the base, you add the exponents. 2 plus 6 is 8. X exponent 8. Okay? The second one, remember, if you have two numbers beside each other in brackets, it also means multiplication. 3x cubed times 5 x exponent 6. Now, when you have two brackets that are stuck together, it also means multiplication. So what we do first is we multiply the coefficients. The coefficient, it tells you how many x cubes do we have. We have negative 3 here, and we have 5 here. So you multiply negative 3 times 5. The second part we can look at is the exponents. Now, if they have the same base, these do have the same base. They both happen to have the base of x. So here we have x cubed times x exponent 6. So when we do the final part here, you see that you have negative 3 times 5 is negative 15. Negative 15. That's my coefficient of my answer. And x cubed times x6, they do have the same base. You add the exponents. 3 plus 6 is 9. And then the final answer, this is the final answer, but if you cannot get an actual value because you don't know what x is. Okay, example number 3 is a little more difficult. It's actually using m's. It doesn't make it any more difficult, but it's good to understand that the variables can be different letters. M negative 2 times 2m. Sorry, negative m squared times 2m. Remember, 2 is squared, 3 is cubed. So, first thing that comes to mind here is, what is the coefficient of negative m squared? You multiply the coefficients first, but if you don't know what the coefficient is, it makes it a little bit difficult. This coefficient is actually This coefficient is actually negative 1. So when we look at it here, it's actually negative 1. So our coefficient is negative 1 times 2. I'll write them out for you. Negative 1 times 2. And then we have m squared times m. So m squared times m. You don't have to do this step, but at first sometimes it makes it easy to understand. So my final answer is negative 1 times negative 2 is negative 2. M squared times m is m. 2 plus 1, remember there's that little invisible 1, m cubed. Okay, last one. Number 4. Negative 5a squared times a cubed times negative a b exponent 4 negative b 5. Here you have a bit of a variety. You have a bunch of coefficients here. I'll underline them. Actually, I think we can highlight. I think that's what these actually are. We can highlight here 5. We have 1 here. We have negative 1 here. We have negative 1 here. Let's put the 1s in. So this is negative 1. This is positive 1. Sorry, this is negative 1. This is negative 1. So if we multiply them out, we have negative 5 times 1, which is negative 5, times negative 1, which makes it positive 5, times negative 1, which makes it negative 5. It doesn't matter what order you do these in. You can go negative 1 times negative 1 times 1 times negative 5. It doesn't matter at all. Now let's look at what we have here. It's a little bit different. We have the a here and a here. We have 1 here. And there are no a's in this side, so you group them all together. So if we look at it, if you group them all together, you have a squared times a cubed times a. And remember, there's a little invisible 1. For the b's, we have b exponent 4 with b exponent 5. So let's write them out beside each other. And like I said, this step you can leave out. b4 times b5. If there's nothing in between letters, it means it's multiplied. So we have our coefficient of negative 5. We put these together. A squared times a cubed times a exponent 1 is a exponent 2 plus 3 plus 1, which is 6. And then b, it's multiplication, b, 4 plus 5 is 9. And that's it.